Hello students, welcome again, and today here what we are going to teach you is about 5 important questions from the topic light, reflection and refraction. These 5 questions in the board exams definitely you are going to see, and I'm not saying that exactly the same question you are going to see in your board exams, but the similar pattern question definitely will be there in your board exams. So watch it very carefully. I will also give you some time to solve them and then we will talk about the solution. Let's start quickly with the first question. So here it is the first question. It is saying that magnification produced by a rear view mirror fitted in vehicle. Option A is less than 1, option B is more than 1, option C equal to 1, or D part can be more than or less than 1 depending upon the position of the object in front of it. So take 30 seconds, try to think about the question and answer it. In the comment box also you can answer, and if you want to think about the answer you can think about it, and after 45 seconds I'm going to disclose the right answer for all of you. Okay, so first of all it is asking you about the magnification. I hope you all remember the definition of magnification. It is the ratio of height of image to the height of object, right? And further if I'm going, it is asking about the mirrors, right? So in mirrors it is also equal to minus V by U, where V is the image distance and U is the object distance, right? So let's see the right answer for this question. The right answer for this question is option A, less than 1. Why? If you remember the convex mirror, in convex mirror we are always getting diminished image, which is also virtual and erect in nature. So if I'm getting the diminished image, and we know that magnification is the height of image to the height of object, and diminished image means definitely the height of image is going to always less than the height of object. So if numerator is smaller than the denominator, the value of magnification always comes less than 1. So convex mirror is used, first of all, which mirror we are using as a rear view mirror, that also is important. So convex mirror we are using here. What is the reason behind using the convex mirror? Because it is a diverging mirror, right? Convex mirror is a diverging mirror and it is giving us the wide range of view, right? That's why we are using it as a rear view mirror. And the magnification in a convex mirror is always going to be less than 1 because the height of image is going to less than the height of object. We remember all the 2 cases that where the image formation is happening, and we are able to see that we always get diminished, virtual and erect image in the convex mirror. I hope it is very clear to all of you. So let's read out the solution also once. It forms virtual, erect and diminished image of the objects. Magnification is the ratio of height of image to the height of object. Hence, magnification produced by a rear view mirror fitted in the vehicle is going to be less than 1. Okay, let's move to the next question. Name the type of mirrors used in the design of solar furnaces. Explain how high temperature is achieved in these devices. So how we are able, because see, solar furnaces if I'm talking about definitely require a high temperature. So how we are going to achieve that high temperature in such kind of devices? Let's discuss it. So first of all, the answer here is concave mirror, and again it is depending on the property of a mirror that concave mirror is converging in nature. All the rays which are falling on the concave mirror, it is going to converge them at a point, and we know that what is that point known as focus. So when a solar furnace is placed at the focus of a large concave mirror oblique reflector, it focuses the light rays parallel. Beam of light on the furnaces, consequently a high temperature is achieved after some time, right? So 2 properties are there. If I'm placing the concave mirror or reflector at focus, so whatever the rays going to fall on it become parallel when they are passing through the focus, right? So I hope you remember it. If there is a concave mirror and the rays passing through the focus and then fall on a concave mirror, after reflection rays become parallel to the principal axis. So same property we are using here. Okay, I hope the question is very simple and clear to all of you. Coming to the next question. Again, a very important question, and definitely this type of question you are 100% going to see in your board exams. Take a note of it and practice few more questions. How you can practice some more questions? You know that there is a feature of CYOT in the Infinity Learn app. You need to download the Infinity Learn app and you can utilize this feature, create your own test. You can go there and you need to select the subject, the type of question, and you can practice the questions there. Now, the image of a candle flame placed at a distance of 30 centimeter from a mirror is formed on a screen placed in a front of the mirror at a distance of 60 centimeter from the pole. What is the nature of the mirror? Find its focal length. If the height of the flame is 2.4 centimeter, find the height of its image. State whether the image form is erect or inverted. Very interesting question. 1 minute I am giving it to you to think about it. You are having 1 minute. Try to think about it. Try to think how you are going to solve this question, and then we are going to see the solution for this question. Your time starts now. Now the few points, if you focus here, it's very important. I'm always saying that whenever you are reading a question, first you should take a note of it, what is given in the question, right? Let's see this question, what it is saying that the image of a candle flame placed at a distance of 30 centimeter from a mirror is formed on a screen placed in the front of the mirror at a distance of 60 centimeter. We all know that usually we are going to place the object always on which side? In the front of the mirror always, right? So object distance is going to be negative, minus 30 centimeter, and image is very clearly given that it is also forming in the screen which is located in the front of the mirror. So V is also going to be minus 60 centimeter. The first thing which we need to find it out, its focal length and what is the nature of the mirror. So if we get the focal length, according with the sign of focal length, we can tell about the nature of the mirror. Let's solve the focal length. Mirror equation, 1 upon f is equal to 1 upon v plus 1 by u. Focal length we need to calculate here. Image distance minus 1 by 60. Object distance minus 1 by 30. So LCM, what we can take here? 60, right? 60 will be the LCM. 1 by f here is equal to, that is going to be minus 1 and minus 2. So it is equal to 1 upon f is equal to minus 3 by 60, which means we are getting 1 by f is equal to minus 1 by 20. So focal length we are getting here as minus 20 centimeter, right? Focal length we got here minus 20 centimeter. So the nature, focal length is negative for concave mirrors, right? So the nature of the mirror is going to be concave mirror. Right? So the mirror is concave and definitely it is converging in nature. If the height of the flame is 2.4 centimeter, find the height of the image. Height of object is already given to you, 2.4. It is asking about height of image, and we already know the value of V, which is minus 60, the value of U, which is minus 30. So I think by using the formula of magnification, we can get it. And it state whether the image formed is erect or inverted. That also we can tell. So first of all, magnification, we all know that it is height of image divided by height of object, which is also equal to minus V by U. So height of image is not given here. We are first using this relation. Height of image is not given. We need to calculate height of object, and definitely the object is always placed in the upside of a principal axis, above the principal axis. So height of object is given 2.4 and the unit it is centimeter. Then it is fine. So it is 2.4 is equal to minus 60 divided by minus 30. So this minus sign get cancelled out. Height of image is equal to minus 60 by 30 into 2.4. The calculation is very simple. Calculate it and tell me. So whatever it is, it comes in a negative sign, and actually the calculation is very easy. Minus 4.8. Am I right? I hope you all are getting the same answer. Minus 4.8, if I am getting here, minus sign, what it is denoting, that it is below the principal axis. If it is below the principal axis, we can clearly say that the image is going to be real, inverted, right? So image is going to be real and inverted. Clear? So in a single question, we saw the use of mirror formula, magnification, right? So it's a very important question, and this type of question will be definitely there in your board exams. Let's move to the next question. The absolute refractive index of ruby is 1.7. Find the speed of light in ruby. The speed of light in vacuum, it is given to you 3 into 10 to the power 8 meter per second. So class, how we can solve this question? So first of all, we know that mu is equal to, mu is a refractive index here, is the speed of light in vacuum divided by the speed of light in that medium. So ruby is the medium here. We can say that it is C by V. So mu is equal to C by V. V we are sending here. So I can say that V is equal to C divided by mu. Speed of light, we already know that 3 into 10 to the power 8, and I think it is also given in the question itself. And the value of mu, it is given 1.7. Now it's up to the calculation only, and the answer come here as a 1.76 into 10 to the power 8 meter per second. Very simple and easy question, but at the same time important also. Next question, what is meant by the power of a lens? Write the SI unit, the standard unit. A student uses a lens of focal length 40 centimeter and another of minus 20 centimeter. Write the nature and the power of each lens. So first question, if you are clear with that, if you clear with what is the power of lens in the formula, the question become very simple for all of you. What is the power of lens? How we can define? Simply, we can say that ability to converge or diverge light rays passing through is known as the power of a lens, and it is reciprocal of the focal length in meter. 1 by f here in meter. If the focal length is given in centimeter, you need to use 100 by f, right? So power of the first lens, 100 by f. Focal length is given for the first lens is 40 centimeter, 100 by 40, 0 get cancel out, 10 by 4, it is plus 2.5. The standard unit for power, it is diopter. It is also asked in the question, right? So standard unit here is diopter. Nature, converging lens, convex lens, how we are getting? Because we can clearly see that the focal length, we know that it is 40 centimeter and focal length is positive, then definitely the lens is going to be here the converging lens, right? Which is convex here. Second one is going to be the diverging or concave lens. Minus, it is focal length is given minus 20 centimeter. We can solve it. Power is coming minus 5 diopter. So the nature is diverging and concave lens. Simple. So these are the 5 questions which are very, very important for your board examination. If you are having any doubt still in any of these questions, you can let me know in the comment box and I'm going to answer them. If I'm answering them in a chat box, you can see the solution there also. Otherwise, I'm going to discuss it in the next class as well. So thank you all. I hope you all enjoyed it. Next time when we are going to meet, we are going to solve 5 important questions of human eye and the colorful world. Okay. So thanks everyone. Bye-bye.